We're going to talk about functions. You've seen these a lot before. A lot of this will look very similar. But first, let's talk about what is a function. And you probably heard this before too. Think of it as being like a machine. All right? I've got a machine here. This is my function rule, which is f. All right? So I've got some x values that I'm going to put in here. This is my input. We send them through f, and then out the other side, I'm going to get some y values, or f of x. And this is my output from the function. So always think about x, or whatever the independent variable is, my input, and my output is your dependent variable. And again, as always, you're used to this. A function has only one output for each input. So in other words, let's say I come back in here. I put a 3 in. I turn my function machine on. I wait a little while, and a 15 comes out. All right, again, I'm not exactly sure what f is in here, but if this really is a function, the next time I put a 3 in, I should get another 15 out. And every time I put a 3 in, I should get another 15 out. However, if I come in one case, I put a 3 in and I get something other than a 15 out, this thing is not a function, but is a relation instead. So you can only have one output, which is your dependent variable for each input. Another way you guys are used to seeing it is it must pass the vertical line test. All right. Evaluating functions, we've dealt with this a little bit already. Here's my function rule. It's over here. Here's my machine. It's 2x plus 1. All right, so now they've given me my input, which is 1. So I put my input into my function machine. And that's what I deal with. Okay. And every time I put a 1 in, I will get a 3 back out again. This won't give me anything else other than that. Okay, well here we don't have a number, but it's the exact same thing. It's 2 times a plus b plus 1. Okay, so now let's step off into the college algebra. I want to talk about piecewise functions. Piecewise functions are functions that are only defined in particular areas. So let's take a look at an example of one. It's going to be equal to x squared if. Now behind this tells you the domain, or the x values, where you're going to use this function. So if x is less than 0. In other words, I only use for negative x values. okay? If x is not negative, then I don't use this function rule right here. And what they do is they give us another piece of this, which is x plus 1. If x is greater than or equal to 0. So what this means is I use this for x equals 0 or x is a positive number. So you actually have to make a decision. So when you come in on this function rule, if x is negative, you use this one. If x is positive or 0, you use only this one. You don't use them both for the same integer. All right, so let's take a look real quickly at what the graph of this is going to look like. This is one of the things you're going to be expected to do is how to graph it. Okay, now remember, I've got x squared here, right? Okay, well we can graph x squared, that's a parabola. You guys can probably do this in your sleep. Okay, but what you have to remember, this only works for negative x values. So I have to go in and I erase these because it's not defined for those at all. It's only defined for the negative x values, and it's also not defined for 0. So I put an open circle there. So this is this piece of the function. You can see why it's called piecewise. I've got just one piece. Okay, so now I come in. You recognize this as a line. I've got a y-intercept of 1 and the slope of 1. So my line looks like this. Now, it's only defined when x is 0 or x is positive, but not when x is negative. So anything which goes off back here on this is not defined. You don't use it, all right? Because this piece only defines if x is 0 or a positive number. So I've got this all messed up. So there's my graph of f. Okay? Now you notice it's not continuous. We've got a jump here. And we'll talk how to handle those a little bit later. Okay, so now let's come back in and say, okay, so what am I going to do? And how do I handle this? Now, you're going to have to learn not just graph these things, but evaluate them, which means plug it in. That's all evaluate means. So let's say I want to find f of negative 3. So the first thing I need to do is figure out where in my domain this is. Since this is a negative, I'm going to use the top piece of this thing. So because my x is less than 0, I'm going to use the top piece. So f of negative 3 is going to equal to negative 3 squared, which is 9. Let's take a look at another one. F of 4. Okay, here because the x I have is greater than 0, I'm going to use the top, the bottom piece. Okay, so f of 4, I'm going to use the bottom piece, and that was 4 plus 1, which will give me 5. So remember, you only work with these things where they are defined in your piecewise function. Okay. Finding domains. These are all possible. X values. And one of the things that's going to trip some of you up is this possible word. Something may be possible in a function, but is not possible in a problem situation. Let's take a look at f of x is 2x. Okay. If we graph this thing, it's going to look like this. So one thing I do is I come back in, I take a look at what's happening on the left side. I'm going off to negative infinity. I'm including all possible negative values. 0 is included in here. I'm also including all possible positive values. In other words, there's no x value in this function that's left out, so my domain is going to be all real numbers. Okay, this isn't necessarily going to be the case for everything, especially deal with rationals. The denominator cannot equal 0. All right, now when I take a look at this thing, I notice that all positive and negative values are possible, except I cannot work with, I can't have the denominator equal 0. So x minus 3 cannot equal 0. I solve for x, so x cannot equal 3. So my domain here is going to be all real numbers, except x cannot equal to 3. We're excluding 3 out of our domain. And if you graph this thing, and you guys need to get used to using Grapher because you're going to be seeing it. All right, I'm going to graph this. So I've got y equals to 1 divided by and I've got x minus 3 inside of here. That's not what I want. Okay. And it was a lowercase x. Okay, so again, when you come over here, when you look at your graph, you notice I've got all my negatives. This thing goes off, but right here at x equals 3, I've got an asymptote. Okay. Last thing is talk about radicals. These are things like Okay, and this is one of the things that Amarillo College has me testing you on, is finding domain of radicals. Okay, and when we're dealing just with real valued numbers, domain is limited to just real value numbers, which means that this thing inside here has to be greater than or equal to 0. So what I want to do is figure out, has to be greater than or equal to 0, or x has to be greater than or equal to 4. And again, if you graph this thing, you'll see that it will only exist between, or for all x values bigger than 4. In other words, my square root function is going to look like that. Okay, it will exist at 4, but if you plug it in and table it, you'll get all errors for these values. Now things get a little weird when you put it in the denominator. Because remember, I said up here, your denominator cannot equal to 0. So what you have to do here is this thing, because it's a radical, not only has to be bigger than or equal to 0, it has to be bigger than 0 because I can't have it in my denominator, or x is going to be bigger than 4, but not equal to